Okay, coat color and lab dogs. So, you probably know that Labrador Retrievers, are popular dogs in many countries. There are 3 recognized colors: black, chocolate, and yellow, although sometimes you can get a silver variety as well. These colors result from interplay among genes that direct production and expression of 2 different pigments called eumelanin and phenylanin in the fur and the skin of these dogs. The first gene, eumelanin, can give 2 different phenotypes, black or chocolate color, in these labs. The 3 recognized colors of labs result from different loci. All of this I'm getting from here. I will let you read this on your own. Gene 2, phenylanin, will allow for the lighter color, the yellow color, to show through because it's more of a recessive trait. Over here we have a list of the traits, genotypes, and corresponding phenotypes. So if you flip your paper over, we are going to pretend that we have bred 2 dogs, and we're going to determine possible genotype and phenotype combinations. So we have a male black lab who is heterozygous for both traits. So hetero means different. Using the chart on the front, we can determine that sorry, my lights went out. We can determine that the genotype for this dog is Big B, Little B, Big E, Little E. So we're looking at different alleles working together. This is called a dihybrid cross because there are 2 di. A female chocolate lab is going to have the genotype Little B, Big E, Little E. We're going to fill this in. Actually, not yet. We're going to use the FOIL method to make sure that these genes are distributed evenly among the offspring. So FOIL stands for first, outer, inner, last. We're going to do that here. So first would be Big B, Big E. Outer, inner, last. And we're going to do this for both dogs. So the female, first, outer, inner, last. These are the combinations that we're going to use to set up our Punnett square. So I'm going to put the first dog that we did, the male, up top. These are all coming from here. And then I'm going to do the female over on the side. And then we're going to combine these just like we did with the monohybrid squares. Keeping the same letters together. This will be important when we start looking at genotype. Big letters go first, small letters go second, Take your time. We're in no rush. Okay, next we are going to calculate percentages of genotype and phenotype. The very first thing I'm going to do is list out possibilities for each. So the very first possibility that you see is big B, little b, big E, big E. I'm now going to go through and cross off all of these that I see, and I'm going to count them. So I see 1, 2, only 2, so I have 2 of these. The next that I see is big B, little b, big E, little e. I see 1, 2, 3, 4. Then I see big B, 1, 2 of those. And then we have, next is little b's, big E's. There's 1, 2, 2 of those. Then we have 1 homozygous, 1 heterozygous. There's 1, 2, 3, 4 of those. And then last we have 1, 2, both homozygous recessive. Next I'm going to calculate my percentages. So there are 16 total squares. I'm going to divide each of these numbers by 16 to find my total percentage. Next, I would use the chart on the front to determine the phenotypes, and I'm writing everything all together right here. So this genotype corresponds to a black lab. This is also black lab, yellow lab, chocolate lab, chocolate lab, yellow lab. And again, I'm getting these phenotypes based off of the given chart on the front. You could then further combine these and say that the chance, if these two dogs were to be bred, a male black lab and a female chocolate lab, there's a 37% chance that the offspring will be black, a 37% chance that they will be yellow, and a 37% chance that they can be chocolate. Same thing here, you can find these using the chart on the front.